Alo. Ok. Hello. Okay. Okay. Yeah. I think we can start our class today. Okay. Hello. Okay. Okay. So today we go to another module which we call this is the blob detections. Uh, so first we will discuss about what is blob, right? So in the image processing, the blob is defined by the something like the connected component. By connected component. So this is by using this one, the connected component, it will form a region. So this we can say that the region is some kind of like object. So what is the connected component? So I think that's already all of you already study about the kernel. So kernel, that is the kind of a connected component. So let's see in more detail about what is the connected component. Okay, so example here, and based on the connected component, the type of the connected component, we will have the object, right? So example here, if we use two kind of connecting component, we will have two object or one object, Okay, so let's define what is connected component. So the connected component is very simple. Example, you have the pixel here. So if we define it is the four connected component. So that means a 4 pixel surround is here. It will connect with the pixel, the center pixel. So that means if the pixel fall in this region, so it will be connected, or it will form one object. It will form one object. Here is the a connected component. So here example here, a connected, so that means it's in the center pixel. So a pixel surround or neighbor, it will connect it with this one, so it will form one object. Okay, so example here example here, if we have the object like this, if we have an object like this, example the object like this. Okay, so if we apply this one, apply the four connected components, so what will happen? This one, right? So this one will connect, right? This one will connect, right? This one will connect. So that means this one is not, this one, if we use a connected component, it will be one object. But here, right, if we use four connected components here, so this one we will consider it, this one is one object. Okay, but this one is different. So if in this case, this one will form five objects. The biggest object is the cross, and the surround object is a different object. Okay, so this is the definition of connecting component or connectivity. Okay, and here is another example. In another example, if we use, if this object, previous object, if we use a connected component, so this we will form one object. But the same, if we use four connected components, so it will form four objects, four different objects like this. Okay, and we will based on this one to find how many objects in the image. Okay, so to find it, is we use something like raster scanning. So what is it? Just go from left to right and up to down like this. Up to right like this. Okay, so we will apply the connected component or a kernel here. We serve on this one from left to right and up to down, and all the pixel related to the kernel, it will form one object. Okay, so let's see the example. We have the object here, we have the object here, the image here, right? So from this one, so how many objects? So let's see. So this is the color image, right? So the first one is we have to change it to the grayscale image, and then we change it into the binary image. Okay, so our raster scan use it in the raster image. Okay, so from this one we will calculate. Okay, so how many block inside? So let's see. Okay, so before, right, they will label it, and the background will be zero. The background will be zero, and the foreground is that means the y pixel. The y pixel, it will be x. Okay, so let's see. Okay, so let's see. Example, they use the connected component like this one, the green label like this, right? So let's see, they scan. Okay, so when they serve one column, right? So because there is no recognition, so right? So the first one is the first, right? The number one, and the second. Okay, so why the second one in number one? Because we use the connected component like this, right? So the center pixel like this here, and this one, this one, the pixel here is connected to the center, right? They are neighbor connected component, so it will become one. Okay, and another similar, right? It will become one. Okay. And here it's similar, right? Because the up label is one, right? It's connect to the center, right? So it's one. Okay. Okay, here, right? Here, right? Because it's the not connect to any the label one, right? So it will become two. Okay. And here is label three, right? And here is two, right? Is two. Here is three, right? Okay, so this position is spatial, right? So this with this connected component, the left is connect to the label 2 and the up connect to label 3, right? So which one they choose? So okay, so in this case they will choose they will give the priority for the lower one. Okay, so this one will become 2. So give priority for the lower one, right? Okay. So at the first scan, we will have four block, right? Four block. Okay, so the scan will finish when you scan many times and the number of blob does not change anymore. So that means you have to scan many times. Okay, so the second scan. Okay. Okay. Oh, sorry. Sorry. Oh, sorry. So why two here? Why two here is three here is become two? So why? So why? Okay, let's see. As I said before, when they scan, and we will have the situation like this. We will have the situation like this, right? Again, right? So because this one they will connect each other, right? So that means they will give the priority for the lower one. So this one will become two again. Okay, two again. So do you have any questions here? Okay, so that means the number of loop, right, will depend on the connected component here, right? So each time you scan, just every number fall inside the kernel, right? And then we will give the priority for the lowest one, So after you scan it, you will have the result. You will have the result. Okay, so that's mean in this case. Okay, so why and after you scan many times, this will become two. Will become two. Okay, so this is the method how to define the blob inside the image. Okay, and this is another example. I think that you can find the example on the internet. Okay, and then you can see the demonstrations. Okay. Okay, and this is another, right? This is for you for practice. Okay, so after you scan, and then you will have this one, have this one. Okay, this one is also for your reference. Okay, this one is also for your reference. Okay, so now in the image, we already calculate how many blob, right? How many blob, and then uh, every blob inside here. Example, we have the blob is like this, right? Every blob they will have the feature. Example, where is this? The position and the size of it, the shape of it, and the orientation of it. So we will go to the next step to calculate those features. First is the position. Okay, example, after you scan an image, right, and you have a blob like this, So how to calculate the position of it? The position, that means the center point, the centroic position. So from uh, traditional calculation, from the traditional calculation. How to calculate the center. That's how to calculate the center. It's very easy. Just scan from left to right, right? Left to right, right? And then this is the minimum u, right? This is the u, right? So you find the u minimum and then you find the u maximum, right? And here, right, you also find the v minimum and v maximum, right? And just do the average and then you have the result, the center. Okay, here example by calculation, you have the u min 150, u max is 250, and this is v min and this is v max, and then the center is just do the average and do the average, just plus and then divide by 2, plus divide by 2, and then the center of it is 200 and 200. Okay, but in the image processing, right, to if you do like this, maybe impossible. Example, you have many objects here, right? Many objects here. So this technique is very slow. It's very slow. So in image processing, they will calculate the central X by another method. We call this the moment. We use moment. So the moment of the bluff is calculated by this equation. Moment. So from here you can see that you have many parameters. Okay, first is what is I and J. So I is the index of U direction. Z is the index of the V directions. P and Q here is the index of the power of the moment. Okay, so example here, we have P equal to Q equal to 0. So that means if we replace this into the equation, right? Replace here and replace here, we have this equation, right? So this one it will equal to M0, 0. Okay, so this is the moment power 1. So the result of this is this one. So this is the area of the blob. Okay, so M00, this is the area of the blob. Diện tích. Okay, area of the blob. Okay, so the equation to calculate the central X of the blob is followed by this equation. The X and the Y is calculated by the M10 divided by M00. As this one. Okay. And the angle or the orientations, because we have just the 2D image. We are a 2D image, so we just have the angle of it. We just have the angle like this. Okay, so this angle theta is calculated by this equation. Okay, so this equation use it. We call this the Hue moment. Okay, so let's go to the detail, right? How to apply this equation. Okay, so the first one I want to tell you that this equation is very important to calculate, because all of you, if you do the image processing, you will meet this angle, especially in your dissertation or final project. You will have to use this equation many times. Okay, so let's go to the detail of this. Okay, example here. If we want to calculate the U and V centroid here, we apply this equation, right? M10 device, right? And by using the MATLAB, they calculate the M01 is this one, is this number, M10 is this number, right? And then they use this number divide this one. Here you can see that. Oh, why? Okay, when we divide, we will have the M10 here, right? So we will have UC here, right? And VC, it is similar. It will be similar. So this equation will similar to your traditional calculation to calculate the centroid of the blob. Okay. So let's see the image, right? So let's see the more detail. Okay. So example in your exercise or in your test, I give you this image. Okay. So what is the centroid of this? How to calculate it? Okay. So first I explain the image first. J here is the coordinate of the pixel, okay? The column coordinate, and this one is the row coordinate, okay? This one is 1, 2, 3, 4, 5, 6, and this is 7, okay? So this one is the index of U and V, okay? So let's see. Okay, the first, how to calculate the JC. How to calculate the JC, that means the U here, right? The U here. Centroid, C is centroid, right? Okay, so let's have a look at the equation. Let's have a look at the equation. This way, I will copy the equation for you here. It's more easy for you. Okay. Okay, I think we don't need it. Okay, let's follow the procedure. Okay. So first, we list on the column, U here, right? And this is the index, right? So as the position 1, we don't have any pixel. But in the position 2, right, we have 2 pixels. Position 3, we have 4 pixels. 4, 5, and 6, right? 6 we don't have, right? 7 we don't have, right? So that means in the U direction, we have the total number of pixels like this. So let's do it first. So let's remember the equation. J will be equal to M01 divide M00. So our task is to calculate M00 and M01, right? So M01, that means we replace P and Q here, right? P equal to 0 and Q equal to 1, right? So after we replace the number, right? So we will have this M01 is here, and then this one is here. Okay. Okay. And as I said before, right? M00, let's see the area of this, right? The area of it. Okay. So M00 will become this one. Okay. And then the formula is this one. Okay. So let's calculate the M01 here. Okay. So here, let me explain more detail. Where is group? Okay, let's see it. Okay, so how to calculate the M01, right? Okay, so let's see. Let's see. So M01 is this formula. So A Ig, this is the intensity up. This is the pixel intensity. So the first one is we will keep the I value, I index. We vary the J value here, right? J value. So J will vary from 1 to 7. So we will rewrite this one into this one. Just replace J here, right? 1 multiply, right? Here, 1, right? And 2, 3, 4, 5, 6, 7. Okay, just J here, right? And then we vary the I index, right? I index. So in here you can see that we will have example 1, right? Multiply of the sigma of this one, right? So A11 plus A21, right? Plus A31, right? Is it? Plus dot, right? Is it? Okay. So what is A11? So let's see. One is the I here, right? This is the I index here, right? So A11 is this one, this position, 11 is 0, right? 21 also 0. 31 also 0, right? So that means this one become 0. Okay. And how about this one? How about this one? Okay, let's see. 2 multiply A 2, right? Sorry, 1, 2, right? 1, 2 plus 2, 2, right? Plus 3, 2, right? Right? Until A 7, 7, right? Okay. So let's see. A1, 2. So what is it? 1 right here, right? And 2 here, right? So this one is this one, right? So it become 1, right? Because this is the intensity is 255, right? So it become 1. A22 is also 1, right? So plus 1, right? And how about the remaining? Is 0, right? So 0. So what is the result? This one is 4, right? 4, right? And similar. Okay. And then we have the result here. This is M01 here. The first is 4, right? Okay. So M01, that means it's very easy. Just multiply. Okay. So here, and then we have the index 2, 3, 4, 5, right? And then just multiply the number here, right? Okay. So after that, and what is the M00? This is area, right? So this is the area. So just count number here. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay. So that means M00 is 17. So that means we have JC will be 4, like this. Okay. And the next one is we will calculate the IC, right? IC. So similar procedure. Just list, right? 2 is 2, right? 2 is 2. And 3 is 4, right? Okay. And then we do the mathematics again, right? mathematics. Just multiply, right? 1 multiply 0, 2 multiply 2, 3 multiply 4, right? And then you have the IC here. And the IC is also 4.3, so it's 4. So the central X of it is 4 like this. Okay, 4 like this. So do you have any questions on the calculation of this one? Do you have any questions? Okay, no, right? Okay. So this one is for calculate the centroid of the blob. Okay. And how about calculate the angle? The angle, right? So we will follow the formula here. Formula here, right? This formula. Okay. This formula. Okay. So in this formula, you have to calculate M20 and M11. Okay. And what is the X bar here? X bar here is XC. And yeah, and Y bar here is the IC. Okay. And then from this one, you can calculate theta. Theta. So let's see the example. More example. Please wait a moment. Exit. Okay, here. Wait. Okay, this is the example. Okay. So example, I give you this one. This one. Okay. So you calculate the central X of it and the angle of it. Okay. So after the scanning, the first scanning, you will have this one, and the second scanning, and then you have two blob, 1 and 5 like this. Okay. And then you calculate the central X, right? The central X, similar, right? And then we calculate the angle. The angle is this formula, right? So the formula is we calculate M20, right? So here, just M20 here, M20 here. So similar calculation of M10. Just replace I now e I power square and calculate similar. The procedure is similar. So here you calculate, and calculate, right? And then after this step, you have this number. And then you calculate u comma 20, u comma 11, u comma 20, comma 11, right? And then replace this value into the equations here, right? And then you have the result here. You have the result here. Okay. Here the result here. So this one is nearly 45 degree, right? So here you can see that the plus one here, is it 45 degree? Yeah, nearly 45 degree. Okay. So this is the mathematics to calculate the plot. Okay. So let's go to the next one. Okay, and the next one is to calculate the length or the perimeter of an object. So we will follow the rules here. If the line If the light go on the 1 pixel, we will calculate it 1. If the light go like this or go like this, we will calculate it the square of 2. Okay, and this one is this one. So let's calculate it. Okay, example here. Example here. Example, we want to calculate the perimeter of this one like this, right? So we have two methods to calculate. First, we call this is the record. That means you just count the number of pixels here. Example one here is 1, 1, 1, 1, 1, 1, 1, right? And we plot it, and you have 18 pixels. 18 pixels. But if you calculate by the newer formation, from here to here, right? This is more precise, right? More precise here, right? So after you calculate, you will have this one. OpenCV will use this method. Okay, OpenCV will use this method. Okay, so previously I already introduced to you how to calculate the M0, right? The moment of the image, right? The moment of the image. This is calculated by manual or by hand. So in the OpenCV, they provide you a function. We call this is the CV moment. CV moment. So in the function, they will calculate everything for you. Everything for you. This is the result of the function. They will give you the moment M00110 here, right? And also from this one, right, you can calculate the U bar 10, right, or U bar 20, right? Okay. So so let's see the step for you to apply the whole moment. First, load the image, and then convert to grayscale. This one is to reduce the noise. This is option, right? This is optional, right? Remove the noise. And then this one you have to do, detect the candy, use candy. And then you have to use the 5 contour equation, 5 contour function. 5 contour function. And then you use the whole moment function. And then you can draw the contour. And then you can calculate the area and the angle. Okay. Here is the example, the previous example. Here, right? And then you use the CV moment to check the result. Okay, let's see. Let's see. Oh, okay, this is in another example. Okay, let me see. Is it another example? No. Okay. Okay, so let's see. Let's see how to use this. Okay, so how to use this? Okay, first you load the image, right? Change it to grayscale, right? And then this is optional, right? Optional, right? And then you do the threshold, right? You do the threshold, right? You do the threshold, and then you do the candy, right? You do the candy, okay? And then this is the procedure to find the contour using the find contour function, okay? And after this step, you have the contour here, the contour parameter here. And then you apply the moment here to calculate the moment of the image. And from this step, this one is the function, okay? CV whole moment, okay? And then after this step, you will have all the parameter here. You just point, right? Point, and then you get the parameter out. And from here, you calculate U11, U20, and U here, right? And then you replace this number into the theta here, the angle. And then you change to the degree, and then you have the result theta. You have the result theta. Okay. So this is the procedure. The procedure. Okay. Okay. So this is the result of this. The result of this. Okay. This is the result. Okay. So this is the result. Okay. Yeah. Okay. And this is another example to calculate the perimeter. So example, I give you this one. This one. Okay. And in the OpenCV, they have the function like the contour area and the arc length like this. Okay. So if you use this function, then we calculate the area of this one and the length of this one and the length of this one. Okay. And the length of this one. Okay. So this is the result. The result you can see. This is the length. This is the length. This is the length. Okay. Okay. So this is the length of this. Okay. And this is another example. It is another example. Example in the image, you have many objects, right? Many objects, and then you also can find all the position inside here, all the position, and the angle. And this is the procedure for you to do it. Sorry. Let me see. This one, right? This one. Just similar, right? Converse to a grayscale, right? Do the rest hole, right? Candy, right? And then find contour, right? And here you have many contour, right? Many contour, and just like you give the index here, contour I, and then you calculate all the centroid, and then just roll it and display it. And this is the code for you to display and roll the contour. Okay. So just follow the code and then you can draw it. You can draw the contour and display the text on the contour. Okay. And let's remember the last example, right? Previously, I already asked you to how to say recognize the purple, right? Something like this, right? And then after the first step, right, you already have this result. You have this result, right? And now how to have the very beautiful image like this, right? So you have to apply the Hue moment. So after you apply the Hue moment, right, you will have many blob like this, and the blob, they will have the area or the side, right? And then you filter the side, and then you will have this one. That means you will delete the blob with the small size, and then you will have this one. Let's see here. After I find the contour, right? After I find the contour, and I will calculate the area of all the contour, but I just roll the contour with the area bigger than 10,000. bigger than 10,000. So because I know that this is the biggest one, so the area bigger than 10,000 will be displayed. It will be displayed here. Okay. Okay. And this is the previous example. Okay. And this is another example, right? Example in here in this picture, I will just recognize the biggest blob, the biggest blob. So the procedure are similar. Find all control, right? Find all control in the image. Find all control in the image, right? And then calculate all the area, right? Calculate all the area, and then just hit the luckiest one. Okay. So let's see the whole moment. Okay. So do you have any question on this one? Do you have any questions? No, right? Okay. So let's see how we calculate the bluff feature. Okay, bluff feature. Okay, let's go to the next one. Okay, the next module is we go to the how transform. How transform. So what is it? So what is it? So let's see some example. Example here. Example in the image. In the image, I give you the matrix of points. So many points like this, right? Many points like this. Okay, many points like this. Okay, so from this image, right? If you want to recognize an object in the image, Oh,
Sorry, can you show the screen? I haven't seen the screen.
Oh yeah, okay, sorry. Okay, so example in the image, I give you a matrix of point like this, right? Many point like this. Okay, so if you want to recognize an object in the image, right? So if you don't know anything or you don't have any information about the object you want to recognize, right? So just random. So in the image processing, they just connect the point for you. Just connect the point, right? Just connect the point and connect the point like this, okay? And if you have a little more knowledge, like example, okay, in the image, I want to recognize the line, the circle, right? So that means you have more knowledge, right? So the image processing will do some kind like connect all the point, the straight line, right, to form a straight line in the image. And if you have more knowledge about the object you want to recognize, example, the heart like this, the heart like this. So in the image processing, they will try to connect all the line to form a heart like this. Okay. So this is the imagery recognition related to the knowledge. Okay. So in the how transform, it will help you to recognize straight line and the circle. So that means in the how transform, you must have the knowledge of what you want to recognize. Okay. So how the transform find the line? Because we know that we want to recognize a straight line. So in the image processing, they will try to find the line of the point. They will try to connect, right? And the how transform is that they will connect all the point, they will choose the line. That go through the biggest of number of point. Example, we want to form in this image, right? We want to form a line. The line must go to at least 10 point. 10 point, right? 10 point. So the how transform will help you to do it. Okay. So let's see what the how transform formula. How can it do it? Okay. So okay, let's go back to the mathematics first. This is the mathematics of the straight line, right? Very common equation, right? Very common equation. Okay, so if we have 2 points, P1 and P2, right? So we will calculate the K and D, right? So we will have the equation of the line, right? Very easy, right? Very easy. So from this one, they will because in this image, right, we have many points, P3, P4, right? So if we use just this one, we don't know how many points, right? We cannot check how many points is related to this equation. So they propose the how transform method. In this one, the how transform do like this. Example, you have many points like this. Okay, so each point, right? They will change to another form that you can. Example, you have 1 point P0 here, right? So there are a lot of lines go through the point, right? Go through the point, right? Okay, so let's imagine that if I have a point here, right? And then I rotate this an angle, example 1 degree. So that means I will have 360 line go through this point, right? Through this point. Okay, so example, I have another point P1 here. Right? P1 here. Example, I do the same. And 60 line, right? Go through this P1, right? And I also have 360 line go through P0, right? But in 360 line here and 360 line here, they will have one line similar. So that means this one have one line, go through it, and this one will have one line go through it. So it will become one here. It will become two lines. First line go through B1, right? First line, second line go through B0, right? And then we have two lines go through B1 and B2. So that means this we vote the number. All the remaining line, right? Just have number one, right? But here we have two lines. So we can see the principal working of transform. Okay. So I explain principal working first, right? And then we go to the detail. From this space, this coordinate to another coordinate, we call this the parameter space. So how can we change it? How can we change it? So let's see. Example, we have the P0 here, right? P0 here, right? And right. So if we replace Y1 here, X1 here, right? So we will have the equation, this equation. Okay. And if we roll it, we have this line in the parameter space. And what does it mean? What does it mean? That means all the point related to this equation represent for the line go through the P0 here. Okay. Okay. So we will example, we have another line here, B1 here, B1 here, right? And we will calculate this, right? And then we will have another equation, something like this one, example like this. We will have another equation, B0, B1 here, right? B1 here, right? And they will intersect at one point here. Intersect at one point here. Intersect at one point here. So from this one, we will know the coordinate of this point, and then we can calculate the equation of the line in the image space. Okay, so let's see. So let's see example here. Example, we have 5 point, right? And each point we will change this to, and then we roll it in the parameter space. We roll it, right? So, and from here you can see that many line intersect, right? So from here you can see that, okay, we have 3 lines connect here, right? And also another 3 line connect here, right? 3 line intersect here. So that means from this space we know that, okay, in the original space we will have the line go through 3 points, because in this graph we have 3 lines intersect, so we will have 3 points. We will have the line go through 3 points. So how to calculate the point here? So let's see. Example, we have the image like this, right? Example here, this you intersect at the number. This one is t equal to 1, right? And k will equal to 0, right? Okay, to 0. So the original is equal to kd plus, sorry, kx, right? Plus d, right? Plus d. Okay. So replace k equal to 0 here, d equal to 1 here. So we will have the equation equal to 1. Is it this one? Is it this one? Okay. Similar. Here, k equal to what is it? Okay. So let's go on. Okay, here. Okay. So in the previous slide, I already introduced to you the method as well as transform. But from this equation, we have a shortcoming. We have a shortcoming. The shortcoming is that if we have a straight line perpendicular with the x coordinate like this, we cannot calculate the k value here because k will equal infinity. So we have to change this form into the house space. The house space and the parameter space are similar, just different equation. Here you can see about the theta and the r here. Okay. And in our image, right? In our image, we have to move the coordinate into the corner right hand side like this, right? So the equation will become this one. Theta and rho like this, okay? And then from here, we will do the House transform. Okay, let's see. Okay, example, I give you this one. Be careful that we also have a point here, okay? Number 2 here, okay? So let's find the line. Okay. So in the previous example, I already tell you that, right? If we have one point here, right? We have to rotate it. 1 degree, right? 1 degree, right? 1 degree. So we will have 360 line, right? But if you do manual like this, right, it will take a lot of time. So I just give you some value, theta. This one. Actually, you have to do what?
you have to vary the value from minus 280 to 180, right? 280, right? But I know that just some value here, some theta value here, it will form a line. So I just ask you to do this one. Okay. So let's do it. First, list all the possible coordinate in the image. Okay. List all. And then give the theta here. And then calculate the R here. Okay. And then you have the table like this one. And after that, you have another table. In this table, you list all the smallest value to the biggest value of the R here. Okay. Example, this way, smallest is this one, right? And the biggest is this one, right? List all the possible case here, okay? And this is the angle. And then do the voting. So let's see. At theta minus 45, right? The minus 0.7 appear 2 times, right? You want to be 2 times, right? Okay. As the theta 0 degree, right? 0 degree, right? Here. The number 2 appear 3 times. This one also theta 90 degree. It appear 3 times, right? 1, 2, and 3, right? So this is the biggest number. So I know that from the original image, there are 2 lines go through 3 points. So how to calculate the equation of it? Let's do this. From here I have to this one, and I have the R value, and it is theta, right? So just replace this one into the equation. This equation. And then from this equation, you calculate that you have this one, right? The remaining is the same. You have this one. So you can rewrite it, right? Is it this one equal to y equal to 3? And this one is equal to x equal to 2? Okay, so this is the how line transform, okay? So do you have any question on this one? I do very, very slow, right? For you. So just follow the procedure to calculate the how line. Okay. Okay. Okay, go to the next one. Is how circle. Okay, so in the OpenCV, they have the function for you. We call this is how line P. They have 2 functions. One function is how line P, and one function is how line. Okay. So in the how line P function, they will give you the coordinate of the lines. But in the how line function, they give you the R and theta. Okay. So let's see the example of this one, how like P. So this is the procedure. And this is the code for the how like P. So do the canny, right? And this one is the procedure to calculate the how like P. And then this is the drawing of the result. Okay. This is another example. Just calculate the how like this. And then you calculate the angle. Use how like B, right? And then you have the lines with the this one is the coordinate of first point, the coordinate of the second point here, right? And then you can do the angle like this. You can do the angle by this equation, okay? And then you have this one, okay? Yeah, this one. Okay, so let's go to another one. We go to the house circle. Okay, so in the house circle, the procedure is similar with the house line. Okay. In the circle, we have the equation like this. All right. So we have to calculate the center, right? The center and the R value, okay? R value. So first we change this into the equation. Calculate to this equation, okay? Okay. Okay, so continue. Okay, so first we change it. Okay. Okay, so by vary the R value and theta value, we will calculate the x0 and y0 here, the center of the circle, and then we will vote for the number of it appear. Number is appear here. Hello. Okay, we continue. Okay, so let's see the example. Let's see the example. Okay. Example here. Example here. Example, I give you the 3 point. X, Y, Y here. 3.2213 and 02, right? So I will ask you, is there any circle go through 3 point? Is there any? So let's do it. So first we vary the theta. So as I said before, right? At each point here, we have to vary theta from 1 degree to 360 degree, right? But here I just give you some point, some important theta, 0, 90, and 180, okay? And about the R value, the radius. When go through 3 point, right? So we have to vary it. So it's also vary from 1 to infinity, right? 1 to infinity. But in this case, I know that, okay, you just do phi r is enough. Okay, so let's do it. So first is theta 0 and r is 1. So we replace this into the equation, right? Into the equation. And this one also, r1, theta is 90, right? Just replace 90 here and r equal to 1 here. We calculate the equation here. We calculate the xc here and yc here. Okay, so let's see the result. Okay, so here, right, the first is this one, and we have the number here. And this one is IC equal to 2, right? And this is equal to 1, right? So it's appear one time. Right? And this one is number 1 and 3, theta 90, right? And it appear the second time, right? So this one appear another time, right? So it appear 3 times, but the remaining just appear 1 time. So this one is the center and the radius of the circle, right? Center and radius of the circle. Okay, so so do you have any questions on this one? Okay, so this is the equation, right? This is the method how to find the house circle. So do you have any questions on this one? The procedure is similar to how line, okay? Similar to how line. Just calculate the number of xc and yc appear, right? So it's appear 1. Here the result is similar. So the xc yc appear 2, right? This one, oh, okay, it's also appear one more time. So it's either 3 times. Okay, so the remaining number just appear one time. Okay, so the highest voting. So from here we know that, okay, xc yc is 1 and 2, and the radius of the circle is 1. Okay, so this is the house circle. how to do it. Okay. So, and this is another example. You can do it at home. Okay. You can go home and then do it. Okay. So in the OpenCV, they also give you a function like the house circle. Okay. Give you the house circle function, and the output is the circle parameter here, and in this one you will have the x, y, and radius. Just point, and then you have the list, and then you will have the value here. Okay. This is the example how to use the house circle function. Okay. And this one is this one. Okay. So why in this one I cannot recognize the outer circle? Because here you can see that we can adjust the min radius and max radius to recognize. Okay, so this one is a house circle function. It's very flexible, so it's very strong, right? You can use it. Okay, so I think this is enough for today. I think so. So do you have any questions on the content? Okay, so if you don't have any more questions, we can dismiss the class now. Okay, thank you for your attendance today.